What we have to take up next is Argand plane and polar representation of a complex number. Okay, so Argand plane is also called as complex plane, as they are telling you here. So what are we doing is we've studied coordinate geometry. Okay, so in coordinate geometry any point used to be represented by an ordered pair, and we had two rectangular axes, the horizontal one x axis, y axis. So that is what how we define a plane. All right, so now when we are doing this for a complex number, so for a complex number, the x-axis, the horizontal line, along this we represent the real part. See, every complex number has two parts to it. Okay, x plus iy. So when I have a complex number, we write it like this: x plus iy, in which we say x is its real part and y is the imaginary part. Okay, so associated with every complex number, again we have an ordered pair. So we can represent a complex number in a plane. And this plane, which is representing complex numbers, the x-axis corresponding to the real part of that complex number, and along the y-axis we consider the imaginary part. This is known as an Argand plane, or that is why we also call it a complex plane. Now next is polar representation of a complex number. Okay, now polar coordinates. We have till 10th you have studied Cartesian coordinates, where suppose there's any point, say this point P out here having coordinates x comma y. That is how we used to write it. Let P have coordinates x comma y. Then we used to understand it as that this length is x along the x-axis. The first one is along x-axis. The second of the ordered pair used to be the displacement along y-axis. So if coordinates of P are x comma y, then this length is x and this length out here is y. So that was in Cartesian system. We call that Cartesian coordinates, okay, or Cartesian system of representing a point. Now, as we said, now this is not a general plane. This is an Argand plane because it is representing a complex number. So if I say P has coordinates x comma y, then that would actually be corresponding to this complex number x plus iy. Okay, x would be its real part and y would be the imaginary part. That is how we have said. Okay, now children, from here this I have written r comma theta. So x comma y are the Cartesian coordinates, and r comma theta, these are the parameters which we call as the polar coordinates. Now what is r and theta here? So as they've shown you, this length, the distance of the point from the origin, the displacement rather I should say, the direct distance of P from, if you join OP, then this length OP is represented by r. Okay, which we also call as modulus. What we were talking about modulus earlier, that any complex number into its conjugate gives the modulus square. That property we had studied. Okay, so that's how we represent modulus of a complex number z, which is represented by r, and r is the first entry of our polar coordinate here. Okay, so it is actually representing this length OP, distance of the point from the origin. And the other parameter theta out here, theta gives you the rotation of this line OP from positive direction of x-axis. We've seen that in trigonometry also, that now when we study angles, then the positive direction of x-axis is taken as our initial line, and in anti-clockwise direction rotation we consider angles to be positive. Okay, so this rotation from here to here, children, theta is the other parameter or other polar coordinate, we can say. These are the polar coordinates, r and theta. So r, I've told you, gives you this length OP, which we call as modulus of this complex number if it is Argand plane, and theta, also known as amplitude or argument, okay, of this complex number. This rotation, we call it as amplitude in some of the books maybe, and most general it is called as argument of the complex number. Okay, now so what are we going to do here is we are going to learn conversion from this form x plus iy form to polar form, polar representation of complex number. Okay, so from here only you can apply geometry and understand it very well, as I've shown you in the figure, that r is this length, and if I say x plus iy, then this length is x, and here this length would be y, right? So if you see, you are getting a right angle triangle here. Okay, so this is hypotenuse of this right angle triangle, so x square plus y square will be length of r. Okay, so that is why this r, which is modulus of z, is equivalent to under root of x square plus y square. That is how it comes. Okay. And now for evaluating theta. So for evaluating theta, or first we've studied trigonometry, so let's talk about each of these lengths individually. If you apply trigonometry, see, for x, if you consider this ratio x upon r, that would give you cos of theta. Cos theta is base upon hypotenuse, so cos theta will become x upon r. Cross multiplying, your x will come out to be r cos theta. Okay. That is why x is coming as r cos theta when we are applying trigonometry. Then next, this is sine ratio, opposite side. So opposite upon hypotenuse. So y upon r will give you sine of theta, which will end up giving you value of y as r sine theta. Okay. सो दैट इज हाउ यू डू इट. सो यहीं से आ रहा है आपका, ये देखो, अगर आप वैल्यू रखो एक्स एंड वाई की यहाँ पे, सो दिस विल बिकम आर स्क्वेयर कॉस स्क्वेयर थीटा प्लस आर स्क्वेयर साइन स्क्वेयर थीटा. आर स्क्वेयर यू कैन टेक कॉमन, साइन स्क्वेयर थीटा प्लस कॉस स्क्वेयर थीटा बिकम्स 1. सो अंडर रूट ऑफ आर स्क्वेयर विच इज आर. That is why value of r comes out to be under root of x square plus y square. Okay. Then for evaluating theta, you have to consider the quotient of these two. If you divide r sine theta by r cos theta, r cancelled, you get sine upon cos becomes tan theta. So tan theta comes out to be y upon x. That is how you'll evaluate or find your argument. Okay. So argument is obtained as tan theta is equal to y upon x. Imaginary part upon real part. Okay. I'll do examples, then you'll understand it better. All right. Okay. So for that, for finding a complex number in polar form, so x plus iy, तो ये फॉर्म तो आपको यहीं से मिल जा रहा है. सी, पुट द वैल्यूज. z which is x plus iy, x we have evaluated as r cos theta plus I times y is r sin theta, तो r common ले लो. Writing complex number this way, this is called its polar form. Okay. So this is in Cartesian form, x plus iy, वही x and y की आप ये values replace कर लो, तो this is polar form. Okay. अब ये polar form के लिए आपको क्या करना होता है, you need to evaluate your r, modulus and your theta and put those values and you can write the complex number in polar form. So for finding r, they've given you the formula already here. R is under root of x square plus y square. If you know x and y, you can find r. Also you can find theta by this relation. Tan theta will be y upon x, imaginary part upon real part. Okay. Now another thing you have to keep in mind here is what they have explained to your children. That is this way. See, the principal argument they are talking about. Okay. So argument, as I said, अब tan theta है, तो theta can be in first quadrant or in second or in third or in fourth. We know that there are 4 quadrants. Okay. So theta एक तो आपका range करेगा from 0 to 2 pi complete rotation में. But अभी यहाँ पे जब आपको देखना होता है, we talk about principal argument and we take the principal argument as from minus of pi to pi. Okay. तो जब आपको argument निकालना होगा, तो what are you going to do is, if we are talking about the last 2 quadrants, third and fourth, तो उसमें हम minus theta ले लेते हैं. Okay. Rather than taking the rotation from 0 to 2 pi, we need to take it from minus pi. ये ऐसे जाओगे तो ये minus pi को correspond करेगा, right? Clockwise चला गया. So minus pi to 0, 0 to pi, ऐसा लेते हैं पूरा rotation. Okay? For what we are calling as principal argument. So as they are saying that we will take the value of theta. Theta out here is representing argument of a complex number. It is to be taken in this range from minus pi to pi, which we call as principal argument, unless specified otherwise. Okay. So in general, जब भी आपसे argument निकालो कहेंगे, तो you'll have to make sure first 2 quadrants में तो fine, first quadrant में theta comes as it is. For second quadrant, you will take it as pi minus theta. ओके. अगर थर्ड क्वाड्रेंट है, तो थर्ड क्वाड्रेंट के लिए यस, ये रोटेशन आपको कैसे मिलेगा, पाई माइनस थीटा, बट उसमें आप नेगेटिव साइन लगाओगे बिकॉज आप क्लॉकवाइज रोटेट कर रहे हो. Do you get that? Okay. So for when we are talking about third quadrant, then argument has to be taken as minus of pi minus theta. That is how you'll go to third quadrant. Okay. And for the last quadrant, it has to be straight away minus theta. Okay. Clockwise में आ गए आप. Clear? Alright, it will become more clear when I'll take up some questions for you. In the meanwhile, you go through solved examples.